Continuing with homework 5, let's proceed to problem number 9. The statement for problem number 9 reads as following. Estimate the machining time required in rough turning a 1.5 meter long annealed aluminum alloy round bar 75 millimeter in diameter using a high-speed steel tool, and B, estimate the time for a carbide tool. Let the feed rate be 2 millimeters per revolution. So for these problems, part A and B, we're asked to find time. And in order to find time for this problem, we need to use two equations. The first equation we need to use is the velocity equation. So V is equal to N, which is RPM, revolutions per minute, multiplied by pi, and D for diameter. In this equation, for this equation, we need to make an assumption for velocity. So part A, we are using high-speed steel. So for velocity of steel, we assume it to be 4 meters per second. Pi is a constant and our diameter is 75 millimeters, or if we convert that over, it's 0.075 meters. Therefore, the missing value we have from this velocity equation is N. So let's go ahead and manipulate the equation so we get N by itself. So N, or RPM, is equal to the velocity over pi d. So let's go ahead and plug in. So once again, our velocity is the velocity of the high-speed steel. So that's going to be 4 meters per second over pi multiplied by 0.075. And N is actually going to come out in revolution per second. So we're going to get 16.97 rev per second. To get that to RPM, we multiply that value by 60. There's 60 seconds in 1 minute. Therefore, we obtain an RPM of 1018 RPM. Now that we have that, we're going to proceed to use the second formula, which is the time formula. So time is equal to the length of the piece, the feed rate multiplied by our RPM. So going back to the problem statement, the length was 1.5 meters, so we have that. Our feed rate was actually 2 millimeters per revolution, so convert that to meters, we have 0.002. And our RPM is 1018. So working that out, we actually obtain 0.74 of a minute. If we want to get seconds, we just multiply that by 60 and we get 44 seconds. So that's the operating time, and we're going to use high-speed steel. Part B is asking the same thing, but instead of high-speed steel, we are going to use a carbide cutting tool. So let's do that. So once again, we have the same equation. V is equal to N pi d. In this case, since velocity or the tool is changed, the velocity for a carbide is 7 meters per second. So let's manipulate the equation once again. So N is equal to velocity, so 7 over pi, and the diameter remains the same, 0.075. This case, we get 29.7 revolutions per second. Once again, let's multiply by 60 to get it into minutes, and we get 1,782 RPM. Now we're ready to plug into the time formula, which recall it's L over Fn. Let's plug in. L remains the same, 1.5. Our feed remains the same, 0.002. Multiply that by our N, which is 1782. And we get 0.42 of a minute. Or multiply by 60 to get it to seconds, and we get 25 seconds. And that is the operation time to rough turn if we were going to use a carbide tool. So that is a solution to problem number 9 for homework number 5.